We are looking at the dice roller mode first. You choose what sort of dice you want to roll, like a 1 through 10 or a 1 through 6. You press one button to increment it, and it's getting stored in memory and added to each time, and another button to reset the whole thing.
Then we're trying the comparator. So if A is equal to B, then it outputs E. If A is bigger than B, which is in this case it is, then it outputs B. Then if B is bigger than A, that means that A is less than B, so it outputs an L. Then we're trying the temperature display. As you can see, that it outputs 21 constantly without any inputs changing it, because the temperature is constant. Then we're trying the NOR gate. As we can see, the output is as shown.
Now Ivan is going through the XNOR mode, and from here on, it's all modes that were originally included in the original ALU. However, we have expanded it, as you'll notice, to have 6-bit inputs for A and B, and an 8-bit output directly to the 7-segment display.
This is the overview of the code, a brief overview. So these are the inputs. This is A, this is B, this is the mode, all from the switches. This is the answer from the ALU. This is the counter, which uses the clock from the FPGA, and this is the output to the BCD to cathodes. So in the first digit case, we're just using the modulo 10 operator to for every number, so that we just get the first digit of that number. If it's an if it's a negative number, we invert it first in the pre-processing, and then take the modulo 10 of it, so that its output's the same but with no minuses. Then for the second digit, we're using an if and else statement. We are checking if the number is less than and bigger than certain values, so that we assign, let's say, 1 to the second digit when the answer is less than 20, so like let's say 15, or if it's less than 20 and it's bigger than 109, so it's 115 again, would assign it as 1, or 200, less than 220 but bigger than 209. So this pretty much all works for the second digit. So whenever we have an negative value that comes in from the ALU, we take the inverse and do exactly the same operations as we do with the positive ones.
So just to go over 2 more quick bits of code, here we have our comparator module. It's a very nice looking sort of recursive module, as it's just going down with case statements within case statements, looking for an XOR to see if one bit between the numbers is 1 somewhere and 0 on the other number, because that's where it can sort of define whether 1 is bigger or not. Here we have our random dice roller mode. Depending on what you input, we have what sort of dice you roll, and we're sort of holding that number in memory and always incrementing upon it. And when it comes to talking a little bit more about successes and failures in doing this project, I think it's pretty important to consider the dice roller module, because that is where we sort of hit a bit of a bump at the last minute, because while it worked rather perfectly without error in simulation, and before we turned in the project, for whatever reason, when we were recording for the demo, it just did not function as expected. So I guess it goes to show that anything can go wrong when you're about to present. But otherwise, I think this project was a good success. We did pretty much what we were planning to do in our proposal, and we went beyond that, like the expanded inputs and outputs for the ALU. And that's our Lab 3. Thank you very much for listening.